Hello. Today we're going to be talking about greenhouse gas emissions in the context of wastewater treatment. So, your wastewater has a carbon footprint. This is often a new concept for people. When we think about carbon, typically transport, agriculture and energy are the first sectors that come to mind. But the transmission and treatment of your wastewater are also included in the global emissions equation. And for local council, wastewater management can make up a significant portion of their total emissions. As part of the Zero Carbon Act, New Zealand must reduce net emissions of all greenhouse gases to zero by 2050. If we do achieve this as a country, we need to understand the makeup of this emission source, how to track it, and how to mitigate it. So how does your wastewater emit greenhouse gases? For wastewater treatment and disposal, emissions occur in four broad categories. The first being the biological treatment stage at your treatment plant. As bugs break down organic material, methane and carbon dioxide are released into the atmosphere. Nitrous oxide is also emitted in the treatment stage as a byproduct of the nitrification and denitrification process. These emissions are influenced by the treatment technologies used, the number of different stages, and the amount of BOD and total nitrogen removed in each stage. The second category is sludge treatment. Sludge will release greenhouse gases as volatile solids are thermally or biologically broken down. The main processes considered in New Zealand are digestion, incineration, and composting. Each of these have different influencing parameters and require a different approach for calculating emissions. For anaerobic digestion, the production and end use of biogas has a significant impact on the carbon footprint of the plant. Is biogas flared or released to atmosphere? Or is it captured and used in a generator or boiler? The third category is the final disposal of biosolids. When biosolids are applied to land, they will continue to degrade and break down, releasing greenhouse gases over time. These emissions are influenced by the origin of the biosolids, such as whether they are primary solids, WAS or digestate, and the moisture content of the exported cake. And lastly, we must consider the final treated effluent stream. While in most cases, the treatment plant has done its job to remove organics and pollutants from the wastewater stream, some remain in the effluent. As treated discharge enters the environment, it will continue to break down and release greenhouse gases over time. In addition to the direct emissions from the wastewater itself, there are other emission sources that can be considered on a treatment site, such as energy streams used to power equipment and the transportation of materials and chemicals. All of these typical emission sources are laid out neatly in a document produced by Water New Zealand called the Carbon Accounting Guidelines for Wastewater Treatment. This document compiles data and figures from recognised global standards and provides a framework for estimating emissions from wastewater treatment in New Zealand. 3 tiers of calculations are presented in the document, each with increasing levels of complexity and accuracy. Level 1, the least accurate method, uses a population-based approach to estimate standard loads for a wastewater treatment plant. Level 2 estimates emissions using specific plant operating data, including sample data and SCADA data. And Level 3, the most accurate method, uses extensive on-site testing to calculate an emissions factor specific to each site. For New Zealand, Level 2 is the most suitable approach, and most councils should strive for this level of analysis. The Level 2 approach is driven by operational data. The exact data required is dependent on the treatment train. However, common requirements are influent flows and loads, effluent flows and loads, sludge mass flows, and biogas monitoring if required. The good news is most plants will already have a lot of this information at hand, and only a few additional samples or instrument readings may be required. But while most councils will have access to this data, figuring out what to do with it can be challenging. To turn data into reporting, the sources need to be scrutinised. Where precisely is the instrument located? Are treatment streams being bypassed? Are there unmonitored flows entering the process? Another aspect to consider is the emissions boundary for the site. Councils may already account for one or more of the emission sources at the site. For example, sludge trucked to landfill may already be considered in the landfill's carbon footprint. Once all these questions have been answered, the final step is for the emissions calculation and report. Typically at the end of the year, all of the requisite information must be gathered analysed and processed using an Excel-based calculation. This can be quite an exercise, especially when it's performed every year. However, with systems such as infrastructure data, the calculation can be automated. Once the reporting is set up, users can monitor and track their emissions on a monthly basis, giving them insight into what's happening at their plant. A batch report collects data on a daily basis, allowing full transparency into emissions across the year. If you're interested in understanding more about your plant's greenhouse gas emissions, feel free to reach out to our team.